Greetings, friends. This is a short little video where we'll be talking about correlations. Correlations are, simply stated, the relationships between variables. We've talked about in this class before the basic way in which variables are related. And we said in previous video that we talked about these basic kinds of relationships. Basically, variables can be the differences between groups or the relationships between variables. Relationships between groups are t-tests and ANOVAs, and in this video we're going to talk about the relationship between variables. And relationship between variables are called correlations. The gentleman behind the development of correlation is a mathematician named Karl Pearson, and that's one of the names of which you will see this particular kind of correlation expressed. It can be called the Pearson correlation coefficient or the Pearson product moment correlation. A lot of different technical names for it. Oftentimes it's just called a correlation, and it's signified by this lowercase r, but called a rho, which is the Greek expression for the letter r is called a rho. And so that will be the term that you will oftentimes see, or the symbol that you oftentimes see to indicate what a correlation is. A correlation basically is a covariance, which means that it describes the way in which two variables relate to each other. A technical definition is a test to determine the tendency or pattern for two or more variables or sets of variables to vary consistently. That means that if you go back to your basic understanding of plotting numbers, way back to Algebra 1 and geometry, you would plot a set of numbers with an x and a y axis, and you would plot along those lines. And the idea being that if there was a change in one variable, there'd be a corresponding change in the other variable. And if there was a consistent or a similar way in which those variables relate, we say that those variables covary. So the way to understand correlations is to think about plotting pairs of numbers or sets of numbers on an x-y axis. So if you were to have, for example, trying to see if two variables related to each other. In this case, the variables would be the amount of time that somebody spends on the internet per week and how depressed they may be. So let's say we gave a person or a group of people a test to determine how likely they are to be depressed. And we wanted to see if there was any relationship between that and how many hours a week they spent on the internet. So here are a group of individuals, and this one column represents how many hours a week they are on the internet, and this is their score on a depression index that was validated by other means. And we want to see if there was a change in one, if a change in one corresponded to a change in the other. Specifically, if a change or if an increase in the amount of hours per week that somebody is on the internet, that also would correspond to an increase in their depression score. And in this instance, it looks like that it was indeed the case. And by the way, this is based on a real study where they have determined that that is indeed the case. The more time that somebody spends on the internet, oftentimes the more depressed they can become. This line right here is called a regression line. It's also called the best fit line, and there's a technical way of determining how that is the case. Basically what they do is they measure the distance between this and any number of possible lines, and whatever line can be drawn that would where the distance between that line and all these points would be the least, that's called the best fit line or the regression line. So basically oftentimes splits the middle of the plotting of these variables, of these pairs of variables. We talk about how slight, moderate, or strong the correlations are. If that correlation is between a 0 and a 0.3, it's a slight correlation. Moderate is between 0.3 and 0.6, and 0.6 and above is a strong correlation. The correlations are always expressed as numbers between a -1 and a +1. And what you look at is the number itself, not whether it's positive or negative, to determine whether or not it's a weak, moderate, or strong correlation. So between 0.1 and 0.3 is a weak correlation, but also between a -1 and a -3 is also weak correlation. Between 3 and 6, moderate, and 6 and 10 is strong. And we call a positive correlation a correlation where when one increases, the other increases. We call a negative correlation where one increases, another decreases, and we'll give you some examples about that in just a minute. SPSS, our software program, will actually correlate for us a matrix, and we'll talk about this a little bit later. But basically what this does is it gives you basically an unlimited number of variables that can be correlated at any one time. And you'll see this matrix oftentimes in research articles. And you'll notice that the numbers 1, 2, 3, 4, 5, and 6 on this side are the various variables. These variables are also across the top, although they don't have the names of the variables written. We just assume this is the first variable and number 2 is the second variable and so on. It's not significant if a variable correlates with itself. We know that it does. So this top line, this is the first variable, has a negative 0.33 correlation with the second variable, which is extracurricular activities. School satisfaction is correlated with the third variable at a 0.24, with the fourth variable at a negative 0.17, and so on. So what this chart will do is tell you at a glance, if you're wanting to see the relationship between a lot of variables, which ones are the most significant. And what we would do is look for the largest number between -1 and +1, and we would take a further look at that. So the power of variables is that, or correlations, is that they can predict future behavior based on past observations. So if you were to see a plotted graph looking like this, you'd be able to infer that the time spent in preparation for a test and the test scores are correlated. The more time you spent on the test, the higher your test score would be. So we can predict in the future that if a student spends more time in preparation, they would have a higher test score. Same here with success in the teaching profession and effective mentoring. The more effective the mentoring, the more success you would have in the teaching profession. We also can have a negative correlation. The number of cigarettes per day and life expectancy after 50. The more cigarettes you smoke, the less likely you would be to live a long life after 50 years old. So what I want to do is give you some examples of different correlations. Now, you in the behavioral sciences, you'll never will see all the plots lying right along the regression line. They'll be clumped on one side or the other. This example here, this is the percent of the population below poverty and the percent of the population with a high school education. So the higher the percentage of people the higher the percentage of people without a high school education, the higher the percentage of individuals in that state living in poverty. So in a state like Mississippi, 22 or 3% of the people live in poverty, 24% do not have a high school education. Same with Louisiana, New Mexico, Arkansas, West Virginia, Kentucky. Now on this side, Arkansas, Minnesota, Connecticut, New Hampshire, low incidence of poverty, low incidences of people without a high school education. We said from earlier that's a moderate correlation or a strong correlation, anything at 0.6 and above. So we would say that this particular correlation is strong. So we know that high school education, not having a high school education, is highly correlated with poverty. This one here, the number of hours that are spent in the program, and the number of errors that a person makes over a set period of time. We can see that the more hours of training, the fewer numbers of errors that person made. The lower the training, the higher the number of errors. A few more education and wages, as you would expect. A percentage of the workforce with a bachelor's degree, more people with a bachelor's degree in that particular population, the higher their salaries. This one is interesting. The percentage of students proficient in math and the percentage of students in poverty. So we know that poverty and math scores are negatively correlated, but fairly highly correlated as well. It doesn't mean that because you're poor, you're going to do poor in math, but those are associated. This one is a rather famous one these days. It's called the Great Gatsby Factor, Income Inequality and Social Mobility. So this is an index for the differences between high and low wage earners. And in these countries, you have greater differences between high and low wage earners. And mobility is the ability from one generation to the next to earn more than your parents. So the higher the correlation, the less likely it is, or higher the number here, the less likely it is that you'll earn more than your parents. The lower then that you will. So these are examples of correlations. You can find them. Literally. Just go do a search on the internet for correlations and go to images. You'll find literally tens of thousands of these. I want to draw your attention to a phenomenon called a curvilinear. You'll see this sometimes in statistics, and it means that the line is not straight. And one of the better examples of how that could be the case is what's called emotional engagement and performance. Low arousal or low care is highly associated with poor performance, and the more you are aroused, emotionally aroused, the more you care about something, the higher your performance is on a particular task. But notice this, that if you are overly aroused or overly concerned or overly worried, then your performance goes down. That's why this section over here is poor performance. So that's called a curvilinear. It's not linear. You just can't keep putting pressure on people and expecting them to perform. So that's will pretty much do give us the basics of correlations. There's some information about how you write up a correlation. Basically, it's pretty easy. You just identify the adjective that would go along with the value. This actually should be 7 there. So so if it's a low correlation, you would say there was a slight positive relationship between one variable and the next. You would describe what the R is, and SPSS will tell you if that number is statistically significant. Moderate, same thing. The R value, and then the P value that is statistically significant. Same if there's a strong. So that gives us a basic idea of correlations. We'll, in a separate video, we'll talk about how to create one on SPSS, and also how to conduct a survey that will give us the kind of data that will be helpful.